All right. Well, welcome back, everyone. Hopefully you had some good conversations out there, and we'll be able to continue them a little later tonight at the reception. I would like to once again thank our all-day sponsors, both the Aerospace Corporation and L3 Harris, for their support. We'll now get started with our next session, AI and space exploration. Sure, Dave, I can do that. This session will explore the role of artificial intelligence in space exploration. The group will discuss AI-driven advancements that achieve efficiencies in the way we work, improve decision-making, and extend human capabilities into new realms. Is AI essential for accelerating humanity's expansion beyond Earth? What about regulation, privacy, bias, and potential risks of relying heavily on AI in unpredictable extraterrestrial settings? Definitely a lot to unpack, so please join me as we welcome this session's moderator, Larry Leopard, Associate Technical Director at NASA's Marshall. Larry.
Thanks, Jim, and good afternoon, everyone, and thank you for joining us for the AI and Space Exploration panel. I'm excited to be your moderator for this panel, and today we've gathered a panel of experts, each with unique insights into AI's role in exploring space and across our space industry. As Jim just mentioned, this panel will discuss how AI is essential for accelerating humanity's expansion beyond the Earth and delving into AI advancements in many different ways. This panel will also address concerns about regulations, ethics, and potential risk on relying too heavily on AI. We do have a jam-packed hour for this panel, so before we get started, I'm going to let each of our panelists actually introduce themselves, and I'm going to start with Tiffany O'Brien. Tiffany?
Hi. Tiffany O'Brien. I work for Leidos. I lead our AI accelerator, and our team works across the enterprise on defense and national security and health and commercial and civil problems. I'm particularly interested in how we can deploy trusted AI in a responsible way that doesn't stifle innovation.
Thank you, Tiffany. Sammy?
Thank you. Hi. Sammy Fadley. I'm a Managing Director at Deloitte. I lead our space innovation team, which involves artificial intelligence as well as harnessing quantum mechanics to build new sets of capabilities where we can actually merge advancements in artificial intelligence across a variety of spectrums, as well as different type of compute to be able to solve both national defense space priorities and challenges, as well as supporting space explorations by making sure that, one, we are advancing the U.S. leadership as it relates to how we bring, responsible AI, ethical AI into various sets of workflows and ecosystems. Thank you.
Thank you, Sammy. Doug?
Yeah, Dr. Doug Manny. So I'm here at University of Alabama in Huntsville. Joined the team a little less than a year ago, but really excited about the momentum that not only you find here on campus, but also within the greater Huntsville area. And so I'll talk about the things that we're doing here, both at the university, plus the experiences that I had standing up the Army, U.S. Army's Artificial Intelligence Center in Pittsburgh in conjunction with Carnegie Mellon and a number of other higher ed institutions. Plus I get a chance to work here in Huntsville with Mayor Battle's Artificial Intelligence Task Force to really accelerate what Huntsville and the local area is doing to prepare itself as a leader, future leader and center of excellence for artificial intelligence support of all the different mission partners here in the area. Thanks.
Thank you, Doug. All right, we're going to begin by asking the panelists some prepared questions, and then we'll have about 10 to 15 minutes after the end of those prepared questions for the audience to ask questions. So let's get started. Here's our first question. Given the expanded space enterprise, what are some of the most promising applications of AI in the space industry over the next decade? Sammy, let's start with you.
Yeah, absolutely. I think artificial intelligence has been revolutionizing the space exploration industry. We've seen that in, the the use of artificial intelligence to build efficient processes, advanced algorithms, harnessing and pushing the boundaries of data analysis across various domains. I think where we see AI playing a much bigger role when it comes to space exploration really is when that shift from AI being a tool that we control by human to a partner in space that can become more dynamic and taking over strategic responsibilities, obviously with some level of supervision and control where we can have more ethics and regulatory frameworks to support that. Imagine an ecosystem that's managed by intelligent spacecrafts that can operate across the solar system. Each of those systems or spacecraft are embedded with intelligent capabilities powered by supercomputers. And those things today are happening. So really the emergence of AI, it's not something that we feel is going to be limited to just using data, but really bringing that autonomous integration to all aspects of space. And that could be from supporting astronauts to harnessing data to advancing the way we understand space as a whole.
Thank you. Tiffany, like to add to that?
So I'd like to add to what Sammy just talked about there, because I think there's maybe three outcomes we really expect from AI, and one comes in the area of extending our reach, new capabilities with autonomous vehicles that now do a much better job of adapting to an unusual environment, an environment they haven't been trained on. But there's also better decision making. So being able to use AI and machine learning to really detect patterns that are a lot more subtle than what we've been able to detect before in a variety of sensor data, and be able to give better information when we're trying to decide and make decisions on what humans are going to do next. And then finally, in efficiency, just sheer workforce efficiency. Imagine an astronaut that's able to ask a question in natural language of a huge amount of data and get an immediate answer that makes sense instead of having to page through literally notebooks of data and information. And that's the sort of thing that I'm excited, all those three outcomes. I think there's a lot of opportunity.
Great. And Doug?
Yeah, I think it's important when we talk about artificial intelligence that we kind of clarify the scope. So it's not just the magic of quote unquote an algorithm. When we think about current and future artificial intelligence capabilities, a lot of what's created kind of the hype for today is based on the advancements, I'll say, at the compute level. But there's a full stack, quote unquote, that you have to think through when you're developing these artificial intelligence capabilities. So it's not just the compute level, it's not just the data management level, because we've seen a fundamental shift going from what we would call analytic functions, which are essentially closed form equations, to now empirically driven analysis. And before we had systems that we would think through and talk about things like emergent behavior. But with what we're able to see now, because of the advancements both in the hardware and software integration, we're seeing generative behavior. And so back to what I believe Tiffany said, where there's this interaction between humans and their supporting systems, that team that we mentioned briefly, you now have a completely different level of human-machine interaction. No longer do you have to, quote unquote, decode the matrix, if you remember that line in the movie. Now you have artificial intelligence that can generate speech, generate images, all of those things that humans are used to perceiving and understanding. And so that whole loop of feedback is going to be fundamentally changed.
Okay, great. Thanks, y'all. All right, so we kind of talked pretty broad there. I'm going to drill in with a more specific question, follow-up question kind of to that one. How can AI be used to accelerate the design, testing, and validation of space systems, particularly in reducing development time and cost? Tiffany?
So I think that's a fantastic area for us to be able to apply AI, all the way from, we're familiar now with the idea of AI-assisted software development, but also system analysis, being able to use AI to create really good digital twins, as in the kind that are able to simulate in a very realistic way an environment, particularly an environment with problems that we may not have in our own natural Earth environment, and simulate situations that you can then be able to test AI and use things like explainability tools to be able to see during the test and evaluation why it's making the decisions it's actually making, through analysis of the training data to make sure that you actually have a good coverage of the different situations that you think you might hit, and therefore you can adjust and say, hey, wait, we're missing data here. So I think there's a lot of capability for AI to really improve what we're doing in test and validation.
Great. Sam?
Yeah, I want to build on what Tiffany has said about the digital twins. I think when it comes to building efficient systems, space systems, we're talking about cost, we're talking about risk, we're talking about the unknown, we're talking about capabilities that need to take in consideration things that we haven't planned today. Now, one of the advantages of artificial intelligence, and you mentioned earlier generative AI, I think there are three areas where we see not just the potential for growth, but where AI, let me just put it this way, where advanced algorithms in deep learning algorithms have been making really a stand. One of them is the ability to prototype digitally, right, as opposed to doing things physically. Because cost, when we make a mistake, there is a cost involved, but also there is the time to market and the ability to deliver capabilities faster than ever before. So I think the digital twin, the simulations using AI, we're able now to use millions of algorithms at the same time across vast, supercomputing GPU workloads to run capabilities and functions that we haven't thought about them in the past. Another area as well, when it comes to optimizing the design and the productivity, is really around cognitive algorithms capable to learn from past missions and be able to adjust their own data sets. So in other words, we are used to databases like what we've seen in the past. Now we have new data systems called vector-driven databases that are basically built upon the structure of a neural network. And these data models, and I'm calling them data models, not algorithms, are capable to manage, integrate billions of various data sets in a millisecond, hence using them across a variety of algorithms at different maturity levels. So as we have these space missions expanding, algorithms are able to learn from past missions, adapt to the unknown, especially when we talk about the unknown in space and the harsh environment and radiations. So all these aspects can't be planned by only human working alone, but that human-AI collaboration is becoming more and more integrated. And the third component is really around unlocking the compute capabilities. So we've seen a lot of things around GPUs. We know a lot of things that we can do on the cloud. As a quantum physicist, one area where we are doing a lot of work right now is really around that quantum AI fusion. We take existing algorithms and we do things that we do typically in large supercomputer workloads, and we encode those capabilities into photons. So we can actually unleash some of the things that we can do in quantum and then bring the data set back to rapidly enable transformers to learn and be able to predict digital twins, but also be able to tell us, well, maybe it's not even worth expanding some areas. Here are some other options for potential testing, simulations, and accelerating production.
Thank you, Doug.
Yeah, so again, back to the nature of the question, I think this is actually probably the best community that I think is going to not only drive the change that's necessary, but also is well positioned to execute it. So had a chance to spend some time with the CEO for NVIDIA a couple months ago. And one of the things that he talks about is, with regard to AI, is he talks about the three-computer problem. And what that is there's the thing that most people think of when they talk about AI and its changes, where there's a large enterprise data center that you use to store all of that data, run it through and develop your model and refine it, right? The challenge is that, one, that's extremely expensive, and second is you have to have authoritative sources for that data that you then curate and label and do all those other types of things that are necessary. Well, when you only have one or two missions every so often, you can't rely on that quote-unquote realistic data. You're going to have to generate through simulation, again, this idea of digital twins, you're going to have to generate your own simulated data. And that's where he talks about the second node going from the data center is this notion of simulated or the omniverse. And so that omniverse is where you can have, again, leveraging the advancements, the same advancements that you have in compute that allow you to perform the mission, you now can leverage that to develop even more elaborate, more fidelity in your models as required before you move to that third compute problem, which is, I'll call it the edge, right, where you're actually executing the mission. And so having the fundamental capabilities, both hardware, software integration, as well as tying into the user, it may be an astronaut, it may be a ground station operator, but you have to have that synergy at the point of mission where you're pulling those things together. And once you have those three computing efforts tying and integrated, that's when you can, basically in real time advance the test and evaluation, because you're going to have to refine and become iterative versus, I'll say, the classic linear or waterfall systems engineering approach.
I want to add just some thoughts just to build on that as well. I think, very often we talk about artificial intelligence and we see the potential. But we also have to realize that despite all these advancements, in most cases, all these innovation that we see happening around artificial intelligence and the buzzword and all those things, we're still using the same technology we've been using for the past 50 years. That's called binary architecture. Hence why the advancements really in terms of unleashing the power of what we can do in terms of artificial intelligence lies mostly on where we can bring that quantum computing capability, where we can start having some hybrid integrated architectures. So when we talk about simulations, again, we have to keep in mind that all these simulations are happening in a binary that is 0 or 1, black or white, but what's in between? And that's what we're trying to really explore and be able to unlock, to be able to address space domain awareness, to be able to teach these advanced deep learning algorithms to be autonomous, to be independent, and to be able to interact with each other, self-correct their models, and to be able to integrate the same human values that we care about as they advance. And to be able to achieve that, really, it's that the intersection between how we do computing today and where quantum can actually deliver capabilities that can get us near to artificial general intelligence and those type of promises that the technology may provide.
All right, thank you. So let's shift the conversation just a little bit here. And I would like to talk about risk and challenges. And the first question, I want it to focus on kind of the technical risk or challenges of implementing AI. Then there will be a follow-on around the ethical and regulation. So let's kind of divide that conversation up. So the first question, where do you see the technical risk in successfully implementing AI applications? Doug, let's start with you on that.
Yeah, so I think as we started the discussion a little bit ago about having these AI systems, where the technical risk lies is a lot of it depends on the integration among those layers of the stack that I mentioned. Because if you don't have, you can have, go buy yourself the latest and greatest GPU cluster and have all the compute that you need. But if you haven't curated your data and it's limited, then of course you develop, I think the term of art is brittle algorithms, right? And so that's always a concern that you think through of an empirically driven approach is only as good as the data that you put into it. Again, that's why we had the discussion about, having, the improvements on the simulation to generate the data that you need to add the robustness, to add, to expand what you can pull into the algorithm. The other part that I think is, again, back to the point is we tend to think of these, purely as a technical solution. And I think ultimately we have to remember that these will not, at least within, I'll say the DoD, I'll pick on the DoD for a little bit. If you look at the DoD policy, those systems do not operate without at least a human on the loop, if not a human in the loop, for a lot of the kinetic type of functions and processes. And so if you're developing these solutions without having that user interface embedded in the actual functional output of the system, then you're developing something that's probably never ever going to be fielded or, I'll say, implemented to the fullest extent that you designed it to be.
That's great. Tiffany?
So, Doug, what you brought up really makes me think of a couple things, because I think you brought up some really good points there. One of them is, the importance of, with these data-driven models, of data-driven methods of the data that you're using, but that also includes being able to monitor and in some way adapt, right? Because you can do the best job in the world trying to train and evaluate, but then once it's deployed and actually working, you can get data drift. Things can change. New objects show up, things you never thought of. And so being able to monitor, I think, is an important, it helps address one of those important technical risks of things changing that you didn't expect along the time. And then the other piece is when you're talking about this human and AI collaboration, there's a lot of possibility for reinforcement learning being used to be able to say, hey, I'm using sort of a game playing approach, and to the human operator saying, how about this, how about that, here's some really good options you may not have thought of, and have that sort of human AI collaboration. But what happens now when you have a lot of latency? Something is up in space. You no longer have that, that very quick response, so human sort of becomes on the loop, not in the loop, and how do you ensure that that's enough time to be able to adjust the way you need to?
Tiffany, I really like where you're taking the conversation. I want to stretch it a little more towards, some similar topics, but I think they lie in the same perspective. To me, when I look at the biggest risk, from a technical implementation, I'm less concerned about what technology or the methods and the procedures, because I think we have very robust frameworks to be able to do that. The biggest concern and the things that I see on a daily basis as I work in the space field, from a space exploration standpoint, the algorithms, the deep learning models, all these things that we do today are being used and trained on data set generated here on Earth. So as we're looking at space exploration, we're looking at the unknown. We're looking at passing stars, we're looking at things that we don't understand, perhaps some physics that we haven't figured out yet. So we need to figure out the best way to be able to incorporate some imaginations that we can generate through what we call today generative AI, right? To be able to simulate and potentially curate some context and complications and challenges of unknown explorations, let's say, on the surface of the moon, and how we want to basically create a hub between the moon and Mars to expand and be able to proliferate some of that space exploration. So the biggest challenge is, how do we train and build advanced algorithms that are not limited to binary architectures that we do very often, to give them the ability to think autonomously and be able to curate using data from space about conditions that are unknown, but also conditions that we can validate and make sure that as we have that human in the loop, off the loop, or on the loop, I think the vector that's for me as a physicist, the vector that's most important is, how can I make sure that artificial intelligence, these algorithms, cognitive systems, are able to think out of the box on their own, using untapped data, so we can anticipate for the things that we are not aware of yet. And I think that is really the intersection of driving innovation, but also making sure that there is a risk-mitigated approach to how we mitigate implementations, but also solve for common standards as we move further towards leveraging artificial intelligence for space systems. And we see some of that in most of the space constellations as well.
So we talked about the technical risk. Do you want us to continue on about
I was going to ask the question. Let's talk about the ethical concerns or regulatory issues, all of that other world that is also required to implement AI effectively.
Yeah.
Go ahead, Doug.
I think that's one of the interesting points to this. So, again, I think there's a question later on where we might talk about workforce, et cetera. But when we laid in and did I'll say the workforce analysis of what it would take to have viable artificial intelligence enabled systems and capabilities. One of the things, other than your data scientists, your roboticists, your machine learning engineer, your data engineer, those types of things. One of the things that we saw that we didn't necessarily have was an actual technology ethicist. And that was something that we brought in very early because they ask those fundamental questions, even as early as when you're thinking about concept development or early in the requirement stage. Is that a function, again, getting back to this question that you posed of, should it be a human in the loop, on the loop, or out of the loop? Those fundamental questions were discussed and brought up as you work through the requirements. And then entirely throughout the process. So as you develop what you thought was, because you didn't have, there wasn't an opportunity to field, quote unquote, a prototype to say, let's go collect the data initially and say, is this something that we can do? We had to ask the question, is this something that we should do? And those kinds of deliberations and trade-offs, I think, are what's also imperative for us to think through. Now, again, having spent 30 years active duty in the Army and then follow on as a senior executive, right, there's a mission. We're going to accomplish the mission. So, but at the same time, there is a responsibility as the developer to enable, and we could talk about astronauts, we could talk about commanders. We wanted to make sure that we gave them the opportunity for their employment decision criteria to say, this is how I'm going to implement this is how I'm going to use it, and it fit their norms, their value structures as the person, that was going to employ that system.
Sammy.
Yeah, happy to add some perspective. I agree. I used to work at NORAD and U.S. Northern Command as CTO, working very closely across the intelligence community and across our defense partners. And frankly, the point you brought up, how we can bring that cohesive, integrated decision-making with some sort of ethics as part of that. It's really not just a human responsibility, because we think of AI as something we can build on our own. But again, we have to build with the ability to let it go and to self-control itself based on values that we care the most about. And I think those design patterns and those principles have to be embedded right from the start. But at the same time, we have to acknowledge as well that we don't have the ability to forecast all the unknown. So I think, one of the promise of, or I would say like what we feel would be kind of bringing us the opportunity to advance some of the ways we design large language models or transformers or all these various models that we can bring to bear is really the integration of new physics vectors that can incubate and integrate a new way of training the algorithm themselves. We have demonstrated some of those capabilities when it comes to national defense in space and how we harness the electromagnetic spectrum to be able to leverage the ionosphere to look for disturbance in the ionosphere to predict hypersonic launches or when we can do certain things that are unpredictable. And I think that lies in a combination of some of the ethics that we control based on our values, but also we have to kind of create algorithms that are willing, by design, to slightly kind of build within that framework, but to think independently. And that's where really the intersection of do we need to have a human in the loop or on the loop, it really depends on the type of AI systems we want to build. And as we look at space and space explorations, we're dealing with a lot of the unknowns. So we want algorithms and AI that can actually help us think forward. And at the same time, we need to make sure that that human team, what I would call like the human AI teaming, is actually embedded on the ethics side. And I think that's where the opportunity for the next generation AI can actually unlock new opportunities for us.
Thank you. And Tiffany, anything to add there?
I'll just add, when I introduced myself, I said I was particularly interested in being able to deploy trusted AI, responsibly in a way that doesn't squash innovation. So to that end, and this is taking a little different direction perhaps than what we were just talking about there, but I think in terms of what we're doing here, it's not just the forward exploration, in a rover on a planet. It's also all the infrastructure that you need to get there, and that includes, IT systems and human capital and all the other things in there where you worry, you look at those risks, and I think it's important that we do be aware of the risks. And is it a safety risk? Is it a privacy risk on data? Are there things we're doing where we might show bias in ways that we don't want to against a group we want to protect? It's important that we be literate and have our workforce be as literate as we can on what those risks are, and then, but then move forward. So that means you understand the risk, and you also then make efforts to mitigate it and watch for it and monitor it. So I think all those risks apply to this domain, but I think there's also ways to be aware of it, approach it, mitigate it, and then still move forward and innovate using AI.
Okay, we've talked about this one a little bit already, but you guys may have thought of something a little different. But the question is, how can we ensure that AI decision-making processes are transparent and accountable to human oversight? I think I heard you had to start that way, but Doug?
Well, I think that's one of those questions that we don't necessarily have all the answers to. So I don't want to take it as though I'm giving you the prescription here. But what I think is important, again, that's actually one of the layers that I described in the AI stack is there's a very explicit, very deliberate approach that you have to understand as you go through the system design. What is it that you're going to codify in terms of the decision support and what types of decisions, if it's a recommendation machine. And I think a lot of things that we've talked about, again, the rheostat can be adjusted, quote unquote, with AI, because what I think some of the capabilities we've alluded to are these cognitive systems where the system actually can learn and go and do its own thing. And so that's one of the fundamental design decisions that you have to put in place when you start out on these systems is it going to be, quote unquote, AI in the sense of, hey, here's the machine learning, it takes this data, it uses this model to give me this recommendation. That doesn't sound as cool as, HAL 2000 or whatever, but it has proven to be significant in terms of its enabling capabilities. So back to the point of how do you have that transparency? Again, this is why I think it's important to have that test sandbox as part of the development that you go through, because again, you'll never truly explore all of it. And somebody brought up a point that I hadn't even thought about is there are certain things that you can simulate with the known physics, but the expectation is we're going to be in locations and in environments that we haven't been before, so you won't necessarily be able to simulate them as accurately as you need to. So I think having practicing the rigor of the data collection as part of the development process is just as important as in having the data so that you can execute the mission.
Tiffany?
So building on that, one of the challenges with AI, and particularly in the last few years, has been that we talk about explainability and transparency, and we have ways to be able to give a good idea of why, what the major factors were when a decision engine, makes a recommendation. But it's very hard to actually really explain how it came to that decision because there's so much data involved in just the methods approached. But I will say that the explainability tools that we have certainly help. This is the likely data that drove this. And we're also now looking at ways to have other AI models help explain the behavior of, AI model number 2 explaining the behavior of AI model number 1, or AI model number 1 explaining its own behavior. And I think we'll probably try to go a lot further in that area and see if that will actually get us to the point where we can understand better why the model is doing what it does.
Same.
Yeah, absolutely. And I concur. I want to add and throw another vector to how we're thinking sometimes about building explainable AI systems. I really think sometimes that we have to also look at past innovations and how we can leverage that innovation. For example, blockchain technology and ledgers are very robust systems that can be used to kind of keep AI on check, right? Because we can't modify the data. It can build a strong ledger where we can see how AI is thinking, but also bring that explainable approach of how we can modify. And I think when we think about generative AI and the integration, or if you want, the fusion between generative AI, what we can do with blockchain and ledgers, the opportunity is really about architecting systems that are by default, right from the start, have the natural transformers to be able to self-explain their decision making. And I think the way we can optimize and modify those things independently, or with the collaboration of another set of AI that are able to leverage those type of data set, is really leveraging these ledgers and creating AIs that would be basically the assistant to monitor how we grow and how we build the system. And I think the best example, if some of you have been using some of OpenAI, AI Assistant, and some of those integrated framework, what you're going to see is that just like the same way we've been thinking about building back in the past multi-threaded applications, well, now we can build various AI applications that each have different roles with human assistance to make sure that we can explain to the AI itself its purpose, why it exists, and at the same time have another set of AI that can leverage blockchain capabilities to help us better make decisions, but also provide that autonomous decision making as part of the algorithmic fabric of the design model.
Yeah, very good, very good. Okay, we've talked a lot about already in the first panel about U.S. competitiveness and leadership. Let's talk about that relative to AI. So maintaining leadership with AI and space exploration will be vital for the U.S. to stay competitive. How can the U.S. foster innovation in AI technologies to stay ahead of the global competitors in the space domain? And how might public-private partnerships play a role in advancing leadership in AI for space exploration? Tiffany.
So AI in particular, you mentioned talking about this earlier. In AI in particular, we have commercial investment at a scale well beyond anything certainly that we can do. I mean, we have to take advantage of it, a huge amount of investment. So how do we work together so we can take advantage of that while still having the ability to, we don't want to get tied into particular architectures or proprietary systems or something else that would hurt our ability to be adaptive and responsive. And so I think the way in which we're going that makes most sense to me is starting to insist on transparency on data and training data, open architectures, and open source where we understand more about how the models were built, and I think that'll be important.
Sammy.
Yeah, thank you. I want to add that I think, number one, artificial intelligence is not just a technology the way we've been building technology in the past, right? So when we think about U.S. space superiority, right, or when we think about the role that the United States plays on a global stage, there are a couple of opportunities, but the one that I feel are very critical, number one is the deep collaboration between academia, the industry, and the government. We've seen tremendous amounts of investments coming from the industry, obviously, because we are driving innovation at a different pace than the government. But there is also, I feel, more momentum from the government, especially if I look at it from a Department of Energy or from a Department of Defense, but I have a bias towards that because I think we have national security reasons where our government has not just committed to advancing our AI capabilities, but also other emerging technologies. So we need to figure out between the industry and the government how we can invest and leverage academia even more than we have been doing it over the past couple of years. Why? Because other competing nations or other actors, they don't operate using the same democratic values that we have. Some, they may wake up in the morning and they may make decisions and they don't need to go to Congress. Others, they have different forms of collaborations. As a United States, we have to control and maintain our superiority. So I think increasing the collaboration, investing in education, merging the realms of physics with engineering. Unfortunately, this is a challenge we have in quantum. We don't produce a lot of quantum physics because either we take an engineering path or a physics path. So having industry with the government, increase investment and leveraging academia even more to solve some of these problems, I think is the secret sauce at the end of the day to be able to establish and make sure that we maintain our leadership in the space, meaning the AI space.
Great. Doug?
Yeah, so thanks for setting up the soapbox, so now I can jump right on. Because I think that, and again, that's why I started off by letting you know I've only been here for a little less than a year, so I don't want you to think I've gone too native in terms of academia. But I will tell you that we need to take a hard look at the interactions and the relationships between academia, government, and industry. Because right now, those silos are so, I think, disparate, they're not going to support and maintain our leadership. So if you look, and I'll give a couple different examples. So it is absolutely essential that you have academia as part of I call it the Golden Triangle. Sorry for Pittsburgh, talk about the Golden Triangle. But you have to have them as one of the vertices there, and they have to be tied in, not just early on, like quote unquote, for basic research, but if you're truly going to adopt the capabilities that we're talking about, they have to be iterative throughout. And I know that there's a lot of IRAD dollars and S&T dollars that industry is putting into their respective research, but you have to, it can be done leveraging academia as that neutral ground where you're fundamentally developing these types of capabilities. And so things like federally funded research and development centers, FFRDCs, UARCs, those are all models that have been implemented over the last several decades. But when you talk to most folks, they tell you, like, we're not going to do a UARC again, right? You're never going to get another UARC approved anywhere because that model, for all the right reasons and the intentions, has not produced what they wanted, which was the speed and acceleration of research to market. And so where I think you have to, bridge that gap is, again, there's the FFRDCs, which, Lincoln Labs up at MIT, Software Engineering Institute at Carnegie Mellon, those have been around. And again, what was the status of SEI? It was to help the Air Force fix software, enabled systems. Well, they're still researching, right? Last time I talked to the Air Force, they're still having fun trying to do software integration onto their platforms. And so maybe there's other mechanisms and models. I'll look at one here. UAH doesn't have to have an FFRDC. It doesn't have to have a UARC. They have research centers that are dedicated research staff that would support the mission partners over here at Redstone Arsenal. And so I think that it takes commitment from the academic side to be willing to do things a little bit different and partner up with the government and the industry folks, because that's the other part of this, right? Is Huntsville, in terms of the community that you have here, I mean, we have industry partners that show up all the time and collaborate with the university researchers on these efforts, to the tune of most of why we're in our R1 research centers, because we have the collaboration and exercise the quote Golden Triangle. So I think that back to Ms. Mears' point, it's going to take a team effort, and we have to get everybody engaged, and everybody has to make that commitment, because if you wait until you have the perfect model, right, then it'll be too late, and we will be talking about other superpowers that are in the lead. So,
just very quickly, and I think one way we can do that, just to build on what you said, is building innovation hubs, right? Because innovation shouldn't be tightly coupled. So we need to have the ability to bring academia, the government, and the industry together. Building innovation hubs that are focused on various capabilities and be able to decouple those type of areas of focus, I think, is critical. And I think that's a way for us to kind of work sometimes outside these very rigid frameworks, because innovation hubs can adapt to any type of priorities we set for them, right? So I think here in Huntsville, we see a lot of these things. In my hometown, Colorado Springs, we have many innovation hubs. Some of them are focused on space domain awareness. Others are focused on missile defense. Others are focused on various, areas of interest. And I think attracting various players into that innovation hub ecosystem is a way we can move forward faster, because we don't operate within rigid frameworks that tend to kind of hold back how that type of collaboration should unfold.
Go ahead, Doug.
I just want to jump on that. So there are 5 innovation hubs that were established last year under NDAA. And the first thing they did was they took their budget of $10 million a year and cut it down to $2 million. The very first thing. So the ideas are out there, but what I'll also say is, so I was picking on the academic side, right? Because we want them to change their thinking that it's not just classroom exercise, et cetera. The other part of this, though, is I think industry needs to figure out, they need to let academia know how they can help them help themselves, right? And that's part of why, as I mentioned, with the task force work that they were doing in Huntsville, they brought in capital investments. Now, that's not about standing up a venture capital portfolio or fund just for AI. It's actually engaging the industry partners here to say, how do we construct this value proposition in such a manner that everybody can win, right? There's the near-term, profits, quote unquote, that you have to have on industry, but yet we have long-term strategic improvements, right? The Bellman's optimality principle applies for research as well.
Yeah, that's great. Okay, I think we're going to stop with our prepared questions. We had one on workforce, but maybe one of those will come from the audience. I know we have a workforce panel coming up here later, but we got about 10 minutes, I think, left for this session. Let's go to questions, Jim, from the audience.
First of all, thank you for the information and for the explanations. My question is, will we be seeing these technologies being already implemented in like the short term, like in the Artemis program, for instance?
I may be the best one to answer that, and it's probably not a great answer. I do know that we are implementing certainly some of those technologies when it comes to that design, evaluation, and test. I could not speak to the operational aspect, certainly of these first missions that we're doing, but I definitely know it's in the planning, thinking longer term for the Artemis missions for sure. But definitely already implementing some of the AI techniques and tools when it comes to evaluating and using the data that we have, for example, off the Artemis 1 mission, and how are we interrogating that data in a way that we can learn from it, maybe from aspects we haven't thought of. So,
hey, Larry, if
yes.
I can help you a little bit.
Oh, go right ahead.
So we are, before we did the Artemis 1 missions, we literally had thousands and thousands and thousands of simulations, and those simulations created a data set, and we used machine learning to go through those data sets to learn things so that we didn't have to have a human looking through every single data set. So yes, machine learning has already been used in Artemis 1.
Thank you, Tony.
Hi, Praveen Baheti, President of SSAI. This question is more about policy. And we have AI. I've noticed that the OSTP and others have gone down different paths on what we can or cannot do in the federal government. And then you also have state governments. I literally feel the technology is outracing the policy development. How can we help the policymakers get policies in place that will benefit everyone?
Anybody got a thought?
Well, so I don't disagree that the technology is rapidly accelerating, and I think that there's two ways to think about it, right? When it comes to policy, there's those that are, the terms I'll use are limitations and constraints, right? Limitations are the things that you can't do. Constraints are the things that you have to do. And if you think about it in that regard, I don't foresee a state where you can have complete exhaustive policy that covers all of those types of things. And so again, that's part of why the approach that I think is helpful is to have not just the ethics expertise as part of the requirements piece, but I think that one of the places where, again, we didn't get a chance to talk about the workforce, but one of the biggest things that I had to deal with over the years was I had to literally try and teach senior policy decision makers how to spell AI, let alone what it actually was. And I don't want to be terse about it, but I think that that's one of the challenges that we really have, is that folks that are empowered to write that policy, they need to be able to either understand it, or we need to have the confidence and delegate those decisions to the folks that are actually developing the capability, and they understand what the quote-unquote rules of engagement are going to be for the implementation of said system. So.
Tiffany or Sammy, y'all got a comment there?
Yeah, I can share some perspective on that. I think, technology is evolving rapidly, and I think it's true for AI. Just the same way data was proliferated a couple of years ago, and we were asking the same question. I think really the U.S. government has been investing and taking some measurable actions that is related to making sure that our policies are adapting to the rapid change. We may not see it on a daily basis. I personally see it on a daily basis from a defense perspective. I can see what our leaders within the Department of Defense, the intelligence communities are doing to make sure that they keep making sure that our policies are enduring, because we deal with things that, technologies that sometimes, if it's in the wrong hands, can have drastic effects on society, but also our leadership in the world. I think it's just a matter of, again, creating these innovation hubs and creating the right forums to be able to have these conversations. And again, asking these questions over and over again and making sure that they become more ubiquitous, because I didn't hear anybody asking me over the past 6 months any questions about policy, because we all assumed that within the Defense Department we're taking the right actions. Is that the case for other departments? I think the right question is, I don't know. But it's definitely something we have to do, and it's something we have to admit that as technology evolves, we have to make sure that we have the right measures in place. And I think sharing knowledge and experiences across departments, but also learning from industry and from academia and bringing that synergy together, I think that would be very helpful.
Great, thanks. Maybe another question or two?
Over far, all the way far left. Thank you. First of all, thank you guys so much for doing this panel. I really appreciate it. Also, shout out Colorado Springs. That's my hometown too. Anyways, my question is about actually regarding energy use of AI. So talking about how much, not just computing power, but like literal energy that it's taking to fuel this AI. Thinking about it from a space exploration perspective, how do you plan on, I guess, thinking about it in terms of if you're trying to implement AI in space? I guess I'm trying to ask about power consumption and sustainability, and what your guys' thoughts are on that.
Can I take this question
Please.
first? Thank you. So I'm putting my quantum physicist hat here to answer some of the questions. So number one, I agree with you. I think when we look at the energy consumption, the impact on the compute, when we use what I would still call, again, legacy technology, I think the impact is drastic, and it's not something that is fully reliable when we think about deep space exploration. Quantum really is an area where the U.S. government, since in fact the previous administration back in 2020, we established what we call the Quantum Innovation Act. And the purpose of the Quantum Innovation Act, which has been spearheaded by the Department of Energy, was really about making sure that two things. One, we want to make sure that we establish our leadership when it comes to quantum information science, but also to solve big problems as it relates to our defense, space, biotech, because we can't just rely on these natural resources that keep generating other affected areas, right? So the reason why quantum is real, number one, I think it's practical. It's been fielded in a lot of areas, and we can have different sessions to talk about it. But when we talk about quantum computing, we're no longer talking about using energy the way we talk about it, but it's about photonics. It's about using cold atom. And NASA and JPL have been doing some amazing work harnessing cold atom. I've been working on other areas very similar to topological quantum for space exploration to be able to put space quantum constellations in space that are currently being fielded, but also to be able to use the energy of the sun as a way to generate more photons and create more entanglements. And these are topics for potentially another time. But quantum computing and quantum sensing are definitely two areas where we can optimize the way we are fueling and creating the right energy to run large workloads that can operate even better outside the typical compute that we work with today. Thank you. And Colorado Springs, we have the Catalyst Quantum Accelerator, and I think our Space Force has been doing some great work in those areas there as well.
Anybody else got a comment there? Okay, let's take maybe another question, Jim.
One of the proposed concepts near the beginning of the panel was using large language models for rapid crew knowledge management. In safety-critical or time-sensitive situations, especially those with communications blackouts or high latency, which are pretty common in a space environment, how do you expect generative AI development to mitigate the inherent risk of AI hallucinations without necessarily having the ability to keep a human in the loop in real time?
So fortunately, there's been research, and we've been proving it out lately, in being able to ground the results of generative AI in real facts, ground them, restrict them to being able to only use information that's been checked against, vetted documents, also against perhaps in some cases a knowledge graph of information that that an analyst has entered and that humans agree is correct, along with guardrails to keep from allowing the questions to be asked in confusing ways in this case, in ways that might get you the wrong kind of answer. So those, along with, and I mentioned the concept of having AI also, other models check the results of the model itself, as well as it being able to explain its own answers. All those together, I believe, really are getting us toward being able to trust what's been generated and only produce information that has been vetted and has sources as well that you can actually ground and believe in. So, really good question.
I would also add that I was just talking to one of my colleagues earlier today about a very similar issue that we're dealing with. I think, there is also a new set of data management technology that's really helping us kind of incorporate some of these vectors as part of the way we control some of the AI behaviors independently from hallucinations. And that's what I would call, again, it's vector data management, which basically mimic the synaptic fabric of the brain, and it's pretty much think of them as neural networks. And those things, the reason why they are very powerful is because, one, when we think about the type of information that we want to control, we want to make sure that stays strict within what a large language model can provide in terms of generative information. Those things, if they're not embedded within the deep learning model themselves and mimicked by a data fabric, and I'm not talking about a data ecosystem, but really the type of data management, like a vector data architecture, then it would be very hard to do. It would just add additional overhead. So I think the industry is kind of adapting to these realities. Please take a look at some of the things, some of the innovations that have been proven. In fact, even some of the leading corporations in AI today are using that type of technology to make sure that this type of risk has been managed. I would also say that when it comes to hallucinations, we're talking about transformers. So I think the hallucination, it's the symptom of binary architecture, hence why we have to kind of start thinking about how we can start adopting a more of a hybrid approach of how we do compute with AI today, just as I mentioned earlier about quantum.
Okay, I think we're out of time here, and we want to thank our panelists for their insights and to everyone for joining in on the discussion today. I think the next panel that's coming up, and I hope you stay and attend, will be with about workforce development with our moderator, Lieutenant Governor Will Ainsworth. So I hope you enjoy the rest of your time here at the Von Braun Symposium. Thank you.